Okay, this is A.REI.6 Algebra Reasoning with Equations and Inequalities 6, Video 3, Solving Linear Systems Using Addition and Subtraction. Here is a term I'd like you to write in your journals and define it, please. Today we are looking at another system of equations, and a system of equations consists of more than one equation at a time, and we are going to try to find the solution in which these two lines will be intersecting, and that intersection point again is called the solution of the system. This is another method we are going to be using. We have graphed the two equations and two unknowns by setting them up into slope-intercept form using a function table and then seeing where they intersect. And we have also used this method called substitution, in which we solved for one of the variables in one of the equations and followed the substitution process. Today is yet another method that we can learn. It's called I guess we can call it elimination, because basically what we're going to be doing is eliminating one of the variables so that we can solve for the other one and use a bit of substitution with this process. So let's see how this goes. First step in the process, what we want to do is make sure that we have our variables lined up with each other. So we're going to do basic column addition or subtraction. And I'm just going to rearrange these two equations and line them up. So maybe we'll put the 13 on the top and the 5 on the bottom. And you're going to notice that we have the x's in line, column style, and then the y's are also in line. And we are going to use one of these operations called addition or subtraction to make sure that we eliminate one or more of the variables. And it looks like if I have a 2 coefficient and a 1 coefficient, if I were to use addition or subtraction, I am not going to be able to get rid of the y term. However, I do look at the x terms and I see that they both have a common coefficient of 1 and -1. And if I were to set up off to the side here a 1 and a -1, and I need them to equal 0, what operation can I put in the middle of my 1 and -1 to make sure that the x's eliminate? Okay, so how about we add? So 1 plus -1 is equal to 0. Now, had I subtracted, I would not have gotten a 0 out of that. So you have to choose the correct operation to eliminate one of your variables, and it's going to be adding. So we set up our columns so that our variables are in line. We've chosen the operation that will eliminate one of the variables. So now I'm going to finish off the line using addition. Positive 2y added to positive 1y is 3y. And then 13 added to 5 is 18. Let's get rid of our coefficient. So we know that y is equal to 6. So if I'm figuring out my solution, my y value is 6. And here's where I was talking about using a bit of substitution in this process. We can take one of our original equations, substitute our 6 in for the y, and solve for your x. So it's going to work in either equation. I'd like you to pick the equation that you feel most comfortable with and then solve. So I'm just going to take the first one. We'll see how this looks. So x plus 2. Let's substitute in our y value, and that's going to equal 13. So x plus 12, and then subtract 12 from both sides. X should be equal to a 1. And just as a proof, let's work the other equation and see if it works also. So negative x plus y, our y is 6, and that should be equal to 5. Subtract 6 from both sides, so negative x is equal to 5 subtracted by 6 is negative 1. Divide both sides by your coefficient. My coefficient is negative 1 in front of the x, so x is equal to, and we already knew that, x is equal to positive 1. Here's another example. Please pause the video and try this one on your own. Okay, we're back. First step is make sure that we have our x and y values in line. And I am again going to take the 50 and put the 26 underneath it. We'll see what that does for us. Let's choose an operation that is going to eliminate one of my two variables. So the operation chosen, well, 5 and negative 1, I'm not going to get a 0 out of that. I do see that I have a 6 and a 6 coefficient. So if I have a 6 and a 6, what can I do to them to get it to be 0? We know that that's going to be subtraction. All right, so let's subtract our lines. Be careful of the signs. It says 5 subtracted by negative 1. So 5 minus negative 1 is equal to 6x. 6 minus 6 is 0, we knew that. And 50 minus 26 is 24. Divide both sides by 6. So we know that x is equal to 4. Let's get that down. Let's go figure out what the y value is using basic substitution method in either one of these equations, and it doesn't matter which one. So let's take the first one. All right, 5 multiplied by x, which is our 4, plus 6y equals 50. Let me quickly do some math here. Subtract 20 from both sides. All right, so 6y is equal to 30. Divide both sides by 6. Y is equal to 5. And I don't want you to forget that what we're doing here is we are finding this ordered pair, kind of robotically here. We're plugging numbers in and we're following a process. But ultimately what we're trying to do is figure out where these two linear equations, these two lines intersect. And we'll be applying this to some word problems when you get to class. All right, I have one more for you. And you're going to notice that the equations look a little different from the first two problems that I put up there for you. So I noticed in the first one, I've got my x and my y on the left and my constant on the right. And in the second one, I only have the y on the left and my x and constant on the right. So we've been working a lot with rearranging equations, manipulating them so that they look the way I need them to look to help me solve problems. So let's take the second one and use some inverse operations to put our x and y on the same side. All right, so the second one, I need my 3x to jump over to the left. And if I take a whole term and throw it to the left, I change its sign. So we have negative 3x. Keep my negative y, I didn't move it. And keep my negative 9 on the right. I didn't move that. Okay, so let's line up our two equations. have negative 3x minus y equaling negative 9. And we're going to just follow the same process. Let's figure out if we're going to add or subtract. It looks like we have the y variable is going to get eliminated. So we have positive 1 and a negative 1. And we have learned that when they're opposite signs, we're going to be adding them. And we're going. So we have negative 8x, this eliminated. And then we have negative 23 plus negative 9, which is a negative 32. Divide by negative 8. X equals 4. We're halfway there. Now we take our negative, or x is positive 4. We take our positive 4, substitute it into one of our two equations. It doesn't matter which one. And let's solve for y. So let's take that first equation. How about, let's choose that color. Negative 5 multiplied by my x, which is 4, plus y is equal to negative 23. And the math, negative 20 plus y. Add 20 to both sides. We get negative 3. Solution. Ordered pair of 4, negative 3. And that is where my two equations of the line are going to intersect when we graph them on the grid. So here was a third way of solving a system of equations. I think we're going to have a few more examples or methods of doing the same idea. And we're going to be choosing the methods in some examples that we think is best at that given time. So given two equations, which method would you choose? Some are easier than others for, depending on what the examples are. And in your journal, I'd like you to define the given terms on page 2 of the flip chart. There's actually one term today. Write a few sentences on what you learned from this video. Jot down any questions that you think you might have that was a little confusing for you. And I'd like you to understand that we are going to be applying this to some word problems in class. So this is just the method. This is just the process of solving. And now we're going to apply this to some real world ideas. I'll see you in class.